Welcome to the Explainer. Today, we're diving straight into a really fascinating framework for the global energy sector, the SASB standard for oil and gas exploration and production. We're going to see exactly how tracking greenhouse gas emissions is no longer just some environmental checkbox. It's actually absolutely crucial for evaluating a company's real-world financial performance. But hey, before we even look at the numbers, I want to pose a question to you. Think about it. When you look at a massive oil rig or a sprawling production facility, what is the greatest hidden risk in oil and gas extraction? You know, it's not always the heavy machinery or the crazy global supply chains or even the wildly fluctuating price of a barrel of crude. The absolute biggest liability is often something you literally cannot even see. Okay, let's dive into this. The answer? It might actually surprise you. The SASB standard explicitly states that the management of the emission of methane has emerged as a major operational, reputational, and regulatory risk. Methane is a highly potent greenhouse gas, and as unconventional resource development expands globally, tracking how much of it just escapes into the atmosphere isn't merely an environmental concern anymore. It is a massive liability that directly impacts a company's bottom line. So, to unpack this complex topic together, here's our roadmap for today. First, the true cost of extraction. Second, unpacking Scope 1 emissions. Third, the reality of flared hydrocarbons. Fourth, methane, the invisible risk. And fifth, managing operational risk. All right, moving right along to Section 1, the true cost of extraction, regulatory and financial realities. What we're looking at here is a rigorously standardized financial accounting framework, which lends immense credibility to tracking these metrics. Specifically, Section EM-EP-110A forces companies to use a common language when they report their direct emissions. For us, that means investors and analysts can finally compare apples to apples across the entire energy sector. No more guesswork. And the standard points out something super vital. Regulatory efforts to reduce emissions obviously create massive compliance costs, right? As governments roll out new climate policies, emitting greenhouse gases becomes incredibly expensive. But there is a totally fascinating flip side here. The standard notes that energy efficiency, like using less carbon-intensive fuels or upgrading processes to capture lost gases, can actually provide direct financial benefits. So reducing emissions isn't just about compliance anymore. It's a brilliant strategic move that cuts costs and boosts operational revenue. Which brings us to Section 2, unpacking Scope 1 emissions, dissecting the data. So what exactly do we mean by Scope 1 in this specific context? Well, to keep us from getting lost in the technical jargon, let's define it clearly. They are direct greenhouse gas emissions from stationary or mobile sources. Think about the physical equipment at well sites, the production facilities, fixed drilling rigs, and even the mobile fleets and marine vessels moving the product around. And according to SASB, these absolutely must be rigorously calculated using methodologies that match up with the established greenhouse gas protocol. Let's move to standard and see how this builds. Because the standard doesn't just accept a single, vague lump sum number. Nope, it requires exploration and production companies to break their Scope 1 emissions down into 5 precise sources: flared hydrocarbons, other combustion, process emissions, other vented emissions, and fugitive emissions. Forcing this breakdown essentially prevents companies from hiding really poor performance in one area behind decent performance in another. It's all out in the open. Let's transition to Section 3, reality of flared hydrocarbons. The visible burn. We're going to zoom in on one of the most highly scrutinized components of emissions: flaring. By definition, flared hydrocarbons are emissions resulting from the combustion of unrecoverable natural gas. This usually happens during routine operations, maybe a system upset or an emergency. You know when you see those giant flames burning at the top of towers at oil facilities? Yeah, that's flaring. It is the intentional disposal and destruction of a hydrocarbon product simply because capturing it wasn't deemed economically or operationally viable right then and there. Here is the real kicker, though. Flaring is not just an environmental issue. In a very literal financial sense, it represents combusted revenue. Every single molecule of gas burned away in a flare is a molecule of product that the company cannot sell. Plus, because it is so highly visible, you can literally see it for miles, it's a primary target for regulators. Companies relying heavily on routine flaring are seriously exposing themselves to both significant financial waste and severe regulatory pushback. All right, moving on to Section 4, methane, the invisible risk.
So because methane is such a massively potent greenhouse gas, the SASB standard actually mandates a very specific accounting rule just for it. Metric EMEP 110A.1 requires companies to explicitly calculate and disclose the percentage of their gross global Scope 1 emissions that come from methane alone. Regulators and investors need to know exactly how much of this specific gas is escaping. Why? Because its impact on the climate, and therefore the regulatory risk it carries, is disproportionately high compared to other gases.
And this brilliantly illustrates a fascinating operational reality on the ground. The SASB standard actually draws a strict line between two types of non-combusted methane releases: vented emissions and fugitive emissions. Vented emissions are intentional. They're designed right into the process, like a pressure relief valve opening up just to prevent an explosion. Fugitive emissions, on the flip side, are totally unintentional. They're leaks from faulty valves, failing pumps, or worn-out compressor seals. Essentially, it's the stark difference between operational design and operational failure.
Now, here is where it gets really interesting regarding these leaks. The standard explicitly states that fugitive emissions can be, and I quote, individually found and fixed to reduce emissions rates to near zero. Near zero. This is huge. It means fugitive leaks are an entirely solvable problem. Because of that, tracking a company's fugitive emissions isn't just tracking some random environmental metric. It's a direct, measurable reflection of management's basic competence and their dedication to facility maintenance.
Finally, let's jump into Section 5, Managing Operational Risk, Strategic Mitigation. To start managing this, companies first have to disclose the percentage of their Scope 1 emissions that are currently covered under limiting regulations. Think of impending regulatory nets closing in globally, things like cap-and-trade schemes or carbon taxes. When a massive slice of a company's emissions is suddenly regulated, their entire cost structure can change overnight. Tracking this percentage shows investors exactly how exposed a company's current operations are to those inevitable climate policy shifts. But, tracking is one thing. The standard actually forces companies to prove that this tracking equals strategic management. They have to detail 3 exact steps. Number 1, setting absolute or intensity-based emission reduction targets. Number 2, detailing the precise mechanisms they're going to use to achieve those targets. And number 3, providing an honest analysis of their performance against their chosen base year. And they don't leave them hanging. The standard even lists out specific acceptable investments companies can use to hit those targets and protect their bottom line. We're talking about broad energy efficiency efforts, diversifying their energy sources, investing in cutting-edge carbon capture and storage, and, absolutely crucially, the implementation of rigorous leak detection and repair processes. These are the physical, boots-on-the-ground, operational investments that shield a company from regulatory fines and lost product. So, what's the big takeaway from all this? Basically, mastering these metrics is the key to surviving the shifting regulatory landscape. Proactive management through process improvements doesn't just help a company avoid penalties, it literally reduces operational costs and secures a long-term competitive advantage. The companies that are going to thrive are for sure the ones that view emission reductions not as some annoying burden, but as a massive opportunity for operational excellence. Which leaves us with this final provocative thought to ponder. Based on everything we've unpacked in the SASB standard today, how is a company's ability to fix a tiny, invisible fugitive leak actually a primary indicator of their overall operational excellence and their long-term investment viability? Seriously, when a financial framework connects the smallest faulty valve to massive global regulatory risk, it proves that in the energy sector, every single detail counts. Thanks so much for joining me on this explainer, and as always, keep questioning the data.